Welcome back to another video here on the Unknown Code YouTube channel. Today we are doing another LeetCode problem, number 118, Pascal's Triangle. So this one is a pretty neat challenge, and you might have seen it around. The problem statement states, given an integer numRows, so numRows right here, return the first number of rows of a Pascal's triangle. Now, I do have a screenshot of the website here. So in a Pascal's triangle, each number is the sum of the two numbers directly above it as shown. So you can see we have 1 here, then it goes down to 1, 1, and then 1, and then this is 1 plus 1 here. So we have 1 at the top, and then 1, 1, and then the third row is 1 plus 1. The next row is 1 plus 2 and 2 plus 1. The third row is 1 plus 2, 1 plus 2, and then 1. And the final row is 1 plus 3. 3 plus 3, 3 plus 1, so on and so forth. So again, let's go ahead and hop down below and take a look at our examples. So for our example number 1, we're going to start out with number of rows equal to 5. So to start out, we obviously start out with 1, so that's going to be the first one. And then the next row, we don't have anything on the left or right, so it'll be 1, 1. So this is going to equal just to an array of 1. This one equals to an array of 1, 1. Then we have 1, then we have 1 plus 1 is 2, then we have 1, so that's going to equal to 1, 2, 1. And then the next row, we have 1 again, then we have 1 plus 2 is equal to 3. We have 2 plus 1 is equal to 3, and then we have 1. So this one will equal to 1, 3, 3, 1. And finally, we have 1 again, and then 1 plus 3 is 4. And then 3 plus 3 is 6. 3 plus 1 is 4. We bring down 1, so that'll be equal to 1, 4, 6, 4, 1. And then basically all we do is just add these into an array. So this will go here, this will go here, that'll go there, and that'll go there. And we'd return that as the value. So that one looks good. Let's go ahead and take a look at the second example. So example number 2 is very simple. It's just numRows equal to 1. So obviously this is only the first row. That'll just be 1. So that will return an array with just 1 inside of it. And that is it. So that one is very straightforward. Let's hop back up, take a look at the constraints, and start talking about how we can solve this. So this problem only has one constraint, and that's just 1 is less than or equal to numRows is less than or equal to 30. So just this means the value of numRows is between 1 and 30. So there's nothing even crazy there. So it's going to be pretty straightforward. So once again here, the goal of the problem is to produce a Pascal's triangle with num's row number of levels. And as described above, in a Pascal's triangle, the next row is produced by summing the numbers above the current index. And to solve this problem, we can start by looking and seeing that every Pascal's triangle is going to start out with 1 on the top. So you can see here, 1. And then after that, the first one and the last one is always going to be 1 as well. So you can see these two are 1, these two are 1. These two are 1, these 2 and 1 as well. So we can also use this knowledge to kind of generate the first 2 rows as well as generate the outside ones. Then after this, we'll keep track of the previous row as well as the current row and generate the current index based off of that previous row, and then continue on until we've done all of the different rows that we need. Let's go ahead and hop down to the pseudocode and do a quick example walkthrough before coding this on LeetCode. So we want to start out by saying for the number of rows to generate, we want to first check to see if the current row is 0 or 1. If this is the case, we're going to go ahead and insert those known values into that current row. Then after this, we're going to say otherwise. What we're going to go ahead and do is for each element in the previous row, we're going to go ahead and add the current value and the previous value. Then we want to go ahead and take that sum and then put it into the current index of this new row. After this, we're going to go ahead and insert that row into our Pascal triangle. And once we've done all of our rows, we want to go ahead and return that Pascal's triangle. So that is our basic logic. Let's go ahead and take a look at the example that we can come up with. For our example, we're going to go ahead and use numRows equal to 5. So we're going to go ahead and say I equal to 0. For I equal to 0, we know this is the first row. So go ahead and set the first row to 1. We know that's the default. Then for I equal to 1, this is the second row. Once again, we know the default value, so we're going to go ahead and set row equal to 1, 1. All right, now for I equal to 2, we're going to get into our actual logic. So now we're going to go ahead and say our previous row is equal to 1, 1. And our target length for this row is equal to 3. So now we're going to say for j equal to 0, we know that the first index of each row is always equal to 1. So we're going to go ahead and set row of j equal to 1, or j equal to 1. Now we're going to say previous j plus previous j minus 1. This is going to equal to 2 because it's 1 plus 1. Then we'll go ahead and set row of j equal to 2. And finally, j equal to 2. Again, we know that the last index is always equal to 1. So go ahead and set row j equal to 1. And then this will end this loop. So now we'll go to I3. Now our previous is equal to 1, 2, 1. And now our length will be equal to 4. So we'll start again, j equal to 0. Once again, this is the first index, and that'll always equal to 1. So we'll set row j equal to 1, or j equal to 1. We're going to say previous j plus previous j minus 1. This is going to equal to 3. So now we'll set row of j equal to 3. For j equal 2, we'll say previous j plus previous j minus 1 again. This will once again equal to 3. So we'll set row of j equal to 3 again. And then for j equal to 3, we're going to know that this is the last index, and that's equal to 1. We'll set row of j equal to 1. That's the end of that loop. Now for I equal to 4, our previous is equal to 1, 3, 3, 1. And now our length is equal to 5. So for now, j equals 0. This is the first index. It's always equal to 1. So go ahead and set row of j equal to 1 for j equal to 1. Now we're going to say previous j plus previous j minus 1. This will equal to 3 plus 1. So this will equal 4. So now we'll set row of j equal to 4 for j equal to 2. Our previous j plus previous j minus 1 is now going to be equal to 3 plus 3, which will equal 6. So now we'll set row j equal to 6 for j equal to 3. We have previous j plus previous j minus 1. This will be 3 plus 1, which will equal 4. So we'll set row j equal to 4. And finally, j equal 4. This will be the last index, which is always equal to 1. So we'll set row j equal to 1. And now we've done all of our iterations. So now we'll go ahead and add all of the rows to the triangles. And go ahead and return the triangle, which is equal to 1, 1, 1. 1, 2, 1, 1, 3, 3, 1, and finally 1, 4, 6, 4, 1. So that is our entire walkthrough. Let's go ahead and hop over to LeetCode and actually program this. So over here on LeetCode, what we're going to go ahead and do is first we need an integer to store our solution. So we're going to say list of a list, and this is going to get a little bit tricky. Integer, I'm going to call this solution, is equal to a new array list. Hopefully I typed everything properly. Then we're going to start the logic. So for int I equal to 0, I is less than numRows and I plus plus. Then inside, we're going to go ahead and make a new list of integers for the current row. This will be a new array list. Then we're going to go and say if this is a first index, so if I is equal to 0, we're in the first row. So then we're going to go ahead and say row.add 1. Then we're going to say solution.add the row. Then we will continue. Then we'll check if I is equal to 1. This means that we're on the second row. So we'll go ahead and say row.add 1, row.add 1, and then we'll say solution.add row. And we'll continue. Then we get into the real logic. So we'll say list of integer. And we'll say previous is equal to solution.get I minus 1. We're going to get the previous row. And then we're going to say for int j equals 0. J is less than or equal to I and j plus plus. Then what we're going to go and do is say if j is equal to 0 or j is equal to I. These are our two edge cases. We'll go ahead and say row.add 1. Otherwise, if that's not the case, we're going to go ahead and say row.add. We're going to say previous.getJ plus previous.getJ minus 1. And that will add those up. Then at the end of this for loop, we need to go ahead and say solution.add row. And then we need to return the solution at the bottom of the first for loop. Now it's a very high chance that I typoed something in here because it doesn't have very good syntax highlighting. Let's go ahead and try to submit this and see what happens. And then we'll try to fix the bug that I can find. Hey, look at that. I did some pretty good typing the first try. We get a 1 millisecond runtime, which will beat 94%. Last time I checked, there's not actually a 0 ms runtime, so I don't know where the 94 comes from, but this is just about as good as you can get. So again, I hope you all enjoyed. If you did find some value in this, please leave a like, comment, and subscribe. And as always, I'm Ethan Uncoder, and I'll see you all in the next video.